What existed before the universe had a name? It is one of those questions that arrives quietly, not with thunder, but in the smaller hours of life, in the silence after loss, in the dark above a sleeping city, in the brief pause between one breath and the next, when the mind looks past its routines and feels, almost with embarrassment, how little it truly knows. For most of human history, the sky offered stories before it offered equations. People looked upward and imagined origins in fire, in breath, in the hands of gods, in eggs of light floating on primordial seas. Those stories were not foolish. They were early maps of wonder, drawn by minds trying to place themselves inside a world that could be beautiful and indifferent at once. Then came telescopes, mathematics, radio signals from the deep, and the astonishing discovery that the universe itself had a history. It had expanded, it had cooled, it had changed. The night sky was no longer a painted ceiling. It was an unfolding record of time. And somewhere behind that record stood the great modern image, the Big Bang, the moment our cosmos began its long journey towards stars, planets, memory, and us. But every answer creates a new edge of mystery. Because if the universe began, what stood at the threshold before beginning? Was there another world crushed into ours like a seed beneath winter soil? Was there only a restless quantum silence, waiting to tremble? Was time already flowing, or did time itself arrive with the first light? And if there was no before at all, what does that reveal about the limits of the human mind, which understands almost everything through cause, sequence, and story? This is where science becomes strangely intimate. These theories are not only about distant origins, they are about the kind of reality we inhabit and the kind of creatures we are within it. To ask what came before the universe is also to ask whether existence has a memory, whether beginnings are ever real, and whether the hunger to know is itself part of the cosmos unfolding. So we begin there at the oldest doorway we can imagine, with light behind us and darkness ahead, listening for what the universe may still be trying to say. What if the first beginning was not a beginning at all, but a local event inside something far older? Imagine a pot of water just before it boils. For a long moment, the surface seems calm. Then a bubble appears, rises, and vanishes. Then another, and another. Each one feels like an isolated event, yet all of them belong to a deeper process already underway. Some cosmologists believe our universe may be something like that. Not the whole boiling pot, but a single bubble in a much larger and possibly endless reality. In the early 1980s, the theory of cosmic inflation changed the way scientists described the newborn universe. It proposed that space expanded with this astonishing speed in its earliest instant, smoothing out irregularities and setting the stage for everything that followed. But one version of this idea pushed further. It suggested inflation may not have ended everywhere at once. In some regions, it stopped, creating universes like ours. In others, it continued, still stretching space and still generating new cosmic domains beyond any horizon we could ever reach. In that picture, the Big Bang was not the birth of everything. It was the birth of our region, our pocket of order inside a larger and ongoing process. Elsewhere, other universes might emerge under different conditions, with different constants, different chemistry, perhaps even different meanings of matter and light. Reality becomes less like a single story and more like weather in an infinite sky. There is something humbling in that idea. We often search for an ultimate first page, a clean origin where all questions can rest. But eternal inflation offers no comforting first page, only chapter after chapter, bubbling outward without visible beginning or final conclusion. And perhaps that is why the theory lingers in the imagination. It does not merely enlarge the universe, it alters the emotional shape of existence itself. If our cosmos is one brief clearing in an endless storm of creation, then the mystery is no longer how something came from nothing. It is how we learned for a little while to call one bubble home. Can a universe die and still leave behind a future? Picture two vast surfaces drifting in a darkness we cannot see. They are not planets, not clouds, not even objects in the ordinary sense, but immense cosmic membranes moving through a higher dimensional space. For ages they travel in silence. Then, at intervals beyond comprehension, they meet. The collision is not an ending. It is a birth. Matter ignites. radiation pours outward. Time as we know it begins again. This is the strange elegance of the cyclic universe. Proposed as an alternative to the standard picture of cosmic origins, it suggests that our Big Bang may have been one event in a sequence without first cause. The universe we inhabit is not the original performance. It is one movement in a composition that has been repeating for longer than language can hold. In this view, existence is not created from absolute nothingness. It is renewed. A previous cosmos expanded, thinned, and aged. Then, through a deeper geometry of reality, it helps set the stage for another beginning. Our universe would be the latest wave after countless others, each one carrying forward the energy of what came before while shedding the details, the names, the fragile records of lived experience. That loss is what gives the theory its human weight. Because if the cosmos is cyclic, then entire worlds may have preceded us. Stars may have burned over forgotten civilizations. Minds may have wondered, as we do, about their place in the dark. Yet when the cycle turned, none of their songs, fears, or discoveries crossed intact into ours. The universe renews itself, but not its memories. It is a wheel that preserves motion while erasing the faces of its passengers. Still, there is comfort here too. The story does not collapse into a single impossible beginning. It becomes rhythm instead of rupture, recurrence instead of accident. The cosmos is no longer a one-time event, but a pattern of endings that become openings. And that leaves us with a question, both scientific and deeply personal. If reality itself survives by letting go, how much of existence depends not on permanence, but on the courage to begin again? What if the universe did not emerge from a grand design, but from a flicker so small it should have vanished almost immediately? In the quantum world, emptiness is never fully empty. Even the vacuum, stripped of matter and light, is restless. Tiny events appear and disappear in intervals too brief for ordinary language. Particles borrow existence, then return it. The void is less like a blank page than a field of murmurs, a place where possibility is never entirely still. Some physicists have wondered whether our universe began as one of those murmurs. The idea is startling in its simplicity. If the total energy of the universe is exactly balanced, with the positive energy of matter offset by the negative energy of gravity, then the cosmos may have required no net energy at all to appear. In that case, the birth of everything would not violate the deepest rules of physics. The universe could arise as a quantum fluctuation, not from pre-existing substance, but from a state so close to nothing that the distinction becomes almost impossible to hold. This does not make the universe trivial. It makes it fragile in a different way. Because a cosmos born from fluctuation is not a monument. It is an event. A vast one, yes. Long-lived, yes. Rich enough to produce stars, oceans, memory, and grief. But still an event within a deeper quantum uncertainty. The ground beneath existence becomes strangely provisional, as though reality itself were balanced on the edge of a whisper. There is something profoundly unsettling about that. We like beginnings that feel deliberate, anchored, necessary. We want the universe to arrive with the gravity of intention. But this picture offers another possibility, that existence may be lawful without being planned, meaningful without being arranged for us in advance. And yet that idea is not entirely cold. A fluctuation can still give rise to beauty. A temporary thing can still contain loyalty, music, and love. In human life, some of what matters most is brief precisely because it is brief. So the question shifts. Perhaps the deeper mystery is not whether the universe came from almost nothing, but how something so delicate became a home for beings capable of asking why anything exists at all. What if universes have ancestors? Stand at the edge of a black hole in the imagination. Not close enough to fall, only close enough to feel the scale of it. A star collapses. Light bends inward. Time seems to hesitate. From the outside, it looks like a grave, the final act of a massive life. But some physicists have asked a more unsettling question. What if, on the other side of that collapse, something new begins? This is the spirit of cosmological natural selection, a theory that treats universes less like isolated miracles and more like generations in a vast evolutionary lineage. In this view, every black hole may give rise to a new universe, one with physical constants altered slightly from its parent. Over immense stretches of cosmic history, Universes that produce many black holes create more descendants. Those better at making stars massive enough to collapse become, in a sense, more fertile. The thought is both elegant and disorienting. The laws of physics we measure so carefully may not be arbitrary nor uniquely ordained. They may be inherited traits. Gravity, particle masses, the delicate balance that allows structure to form, all of it could be the result of a long cosmic selection process unfolding across realities we will never see. And where does that leave us? In one sense, very small. If universes reproduce through black holes, then our existence may be a side effect of a deeper pattern that has nothing to do with consciousness. Galaxies are not arranged for our sake. Stars do not burn in order to produce meaning. The cosmos may be tuned, but tuned for collapse, not for us. Life would emerge in the margins of a process aimed elsewhere. Yet there is another way to hear this story. Evolution on Earth produced eyes without planning beauty, and still beauty appeared. It produced minds without aiming at philosophy, and still questions arose. A universe shaped by blind selection could also give rise to tenderness, memory, and moral imagination without ever intending them. Perhaps that is the quiet grandeur of the idea. We may be incidental, but not insignificant. Born from a lineage we did not choose, carried forward by forces indifferent to our hopes, we are nevertheless here, able to look into the dark mouths of black holes and wonder whether creation has been happening there all along. What if the end of the universe is not a wall, but a doorway too stretched and subtle for ordinary intuition to recognize? Imagine a shoreline at dusk. The tide has gone out so completely that sea and sky almost lose their distinction. Distance becomes difficult to judge. Shapes flatten. Time seems to loosen its grip. Roger Penrose's conformal, cyclic cosmology begins in a similarly strange landscape. A universe so old, so diluted, so emptied of structure that size itself no longer matters. In this theory, the remote future of our cosmos and the fiery birth of a new one may be two versions of the same geometry. As the universe expands for unimaginable ages, stars burn out, black holes evaporate, and matter itself may decay. Eventually, only massless particles remain. For such particles, scale has no meaning. A universe that is infinitely large and cold can, mathematically, resemble one that is infinitely dense and hot. The end becomes compatible with another beginning. It is a haunting proposal because it does not merely suggest that something came before us. It suggests that traces of that earlier cosmos may still be faintly visible now, carried in the oldest light we can observe. Penrose and others have argued that subtle patterns in the cosmic microwave background could be relics of violent events from a previous eon, as if our sky still holds the dim afterimage of a universe that died before ours was born. Whether those patterns are genuine signals or artifacts remains debated. The evidence is uncertain. The mathematics are bold. And between them lies the fragile territory where science often does its most honest work. Not certainty, but disciplined imagination. What gives the idea its emotional power is the possibility of inheritance without memory. A prior universe may have passed something forward. Not stories, not names, but a faint structure, a whisper in radiation. Its life is over. Its interior world is gone. Yet it may have touched us anyway. And that raises a tender possibility. Perhaps no ending is entirely sealed. Perhaps even in a cosmos destined for silence, something continues, altered beyond recognition, but not wholly lost. If so, then the universe is not a sequence of isolated acts, but a long relay of light, each world handing the next a message it cannot read itself. What if depth itself is a kind of translation? Think of a hologram held in the hand. On its surface, there is no real room, no actual distance, only encoded patterns waiting for light. Yet when illuminated, an image rises from it with a convincing illusion of shape and volume. Some of the most profound ideas in modern physics suggest that our universe may work in a similarly unsettling way. The world we experience as spacious and solid could be the projection of information written on a more fundamental boundary. The holographic principle emerged from attempts to understand black holes, those regions where gravity becomes so extreme that ordinary ideas about space begin to fail. In trying to resolve the paradoxes surrounding what black holes remember and what they erase, physicists were led to a remarkable possibility. The information contained in a volume of space may actually be described by data stored on its outer surface. Reality in that case would be less like a filled container and more like a generated image. If that idea reaches all the way to the cosmos itself, then the question of what came before the universe changes shape. Perhaps there was no earlier three-dimensional world waiting in darkness. Perhaps what preceded our familiar reality was a different state of underlying information, some prior arrangement on a boundary beyond direct perception. The Big Bang would not be the ignition of matter in space so much as a transformation in the code from which space emerges. There is something deeply disorienting in this. We trust distance, we trust touch. We live by the feeling that things occupy places and that our lives unfold inside a genuine depth of world. But the holographic view suggests that what feels immediate may be derivative, the lived interior of a deeper architecture we never encounter directly. And yet human life is full of such layers. Memory is not the event itself, but a reconstruction. Music is not emotion, yet it carries emotion faithfully enough to move us. A map is not the territory, yet sometimes it leads us home. So perhaps the question is not whether the universe is a projection, but whether projected things are any less real to those within them. If our world is an image cast from hidden information, does that diminish its beauty, or does it make existence even stranger and more worthy of wonder? What if our universe began not with creation from nothing, but with recovery from collapse? Picture a cathedral made of glass slowly folding inward under its own weight. The arches bend, the light narrows. Every window, every reflection, every open space is drawn toward a single unbearable compression. Then, at the point where collapse seems absolute, something unexpected happens. The fall does not end in destruction, it reverses. The structure opens again, violently, brilliantly, becoming not ruin but release. This is the intuition behind the Big Bounce. In several approaches to quantum gravity, the Big Bang is not a true beginning, but a transition. A prior universe, instead of collapsing into an impossible singularity where physics breaks down, may have reached an extreme density and then rebounded. Space itself at the smallest scales is thought by some theorists to possess a discrete, granular character. Under those conditions, compression cannot continue forever. The fabric of reality resists. Gravity gives way to quantum pressure, and contraction becomes expansion. The idea changes the emotional grammar of cosmology. A singularity is a wall, a place where explanation ends. A bounce is different. It is a threshold. It suggests continuity where we once saw rupture, history where we once imagined only. Before our cosmic dawn, there may have been another universe aging toward its own conclusion, carrying stars, dark matter, perhaps even worlds with their own forms of weather, language, and longing. But if such a universe existed, almost none of its details survive intact. The bounce would preserve structure only in the broadest sense. Individual histories would vanish. Civilizations, if there were any, would be compressed beyond recovery. The universe could have a past while remaining, for all practical purposes, amnesiac. That may be the most human part of the theory. We know what it means to be shaped by what we cannot remember. Lives are often formed by inherited forces whose names have been lost. Families pass down gestures, fears, resilience, and silence long after the original stories fade. So perhaps our cosmos is like that too, a being with a past it cannot fully recall. And if the universe itself was born from survival, rather than absolute beginning, then maybe existence is less a miracle of appearance than a miracle of endurance. What if the universe was never made at all? There is a moment in mathematics when a pattern feels less invented than discovered. A theorem does not seem to come into existence because we wrote it down. It seems to have been waiting, silent and intact, until someone learned how to see it. The mathematical universe hypothesis takes that feeling and extends it beyond comfort. It proposes that reality is not merely described by mathematics. Reality is mathematics. In this view, our universe is not a machine assembled in time, nor a stage built for matter and light. It is a self-consistent structure, something that exists in the way numbers and geometric truths exist. The equations do not point toward a deeper physical thing hiding behind them. The equations are the thing. Existence is not constructed from substance first and then governed by law. Law and being are inseparable. If that is true, the question of what came before the universe begins to dissolve. Before applies to events. It belongs to sequences, to change, to clocks and causes. But a mathematical object does not wait to be born. It simply is. A triangle does not emerge from yesterday. A prime number is not younger than the person who first understands it. Likewise, the universe, in this radical picture, has no earlier condition because it does not depend on a process of creation in the ordinary sense. The theory is austere, almost severe. It offers no cosmic drama, no primordial fire, no hidden workshop where reality was forged. Instead, it gives us something colder and stranger, a world that exists because it can't exist without contradiction. And if every consistent mathematical structure exists in this way, then our universe may be one among an unimaginable multitude, each equally real within its own internal logic. Yet there is a quiet beauty here too. It suggests that existence is not arbitrary. The cosmos may be intelligible because its deepest layer is intelligibility itself. Our minds, made of matter and thought, can grasp fragments of the world because both mind and world participate in the same underlying order. Still, a troubling question remains. If we are patterns inside a mathematical structure, what does that make of freedom, of sorrow, of love? Perhaps the mystery is no longer how the universe began, but how abstraction learned to feel like a life from the inside. What if the question itself breaks apart at the edge of the beginning? We live by sequence. Morning follows night. A seed becomes a tree. A word leaves the mouth and reaches another person a moment later. Human thought is braided from before and after, cause and consequence. So when we ask what existed before the universe, the question feels natural, almost unavoidable. But near the origin of reality, some physicists believe nature stopped speaking in the grammar we rely on most. At the smallest conceivable scale, space-time may not be smooth at all. John Wheeler imagined it as a kind of quantum foam, a seething microscopic turbulence, where geometry fluctuates wildly, and the distinction between here and there, earlier and later, begins to lose its meaning. In that domain, the ordinary stage on which events unfold is no longer stable. Space curls, time trembles. The categories that make experience intelligible to us become unreliable. This is part of what gives force to the no-boundary proposal associated with Stephen Hawking and James Hartle. As one traces the universe backward toward its earliest state, time may gradually behave less like time and more like a spatial dimension. The beginning is not a sharp edge with a clock ticking just before it. It is more like the North Pole, a limit to a direction, but not a place beyond which one can continue asking for something farther north. If that is right, then before the universe may be a phrase without physical meaning. Not hidden meaning, not difficult meaning, no meaning in the strictest sense. The problem is not that the answer is buried from us. It is that the framework of the question fails exactly where we most want it to hold. There is something humbling, even tender, in that possibility. Human intelligence is extraordinary, but it evolved to survive among middle-sized things, falling stones, seasons, faces, firelight. We may be asking ultimate questions with minds shaped for local weather, and still we ask. Perhaps that is the point. The dignity of inquiry does not depend on guaranteed answers. Sometimes the deepest truth is learning where language, intuition, and even time itself begin to thin out. At that threshold, mystery is not ignorance waiting to be defeated. It may be part of reality's original texture. What if our universe is not the most likely reality, but only the most elaborate one we can still believe in? In the 19th century, Ludwig Boltzmann confronted a puzzle that still shadows cosmology today. The laws of thermodynamics tell us that disorder tends to increase. Left alone long enough, a closed system drifts toward equilibrium, toward sameness, toward a state where nothing remarkable should happen. And yet our universe began in astonishing order. It emerged with the delicate, low-entropy conditions needed for stars, chemistry, memory, and eventually consciousness. The improbability of that opening is almost beyond language. Boltzmann imagined an answer both elegant and unsettling. If reality, on its largest scale, were an eternal sea of equilibrium, then random fluctuations would inevitably occur. Given enough time, even extremely unlikely patterns would arise. A brief pocket of order might appear by chance, like a rare ripple crossing a still lake. Our universe, in this view, would be one such fluctuation, not necessary, not designed, simply statistically possible in an infinite background of thermal sameness. At first, the idea seems to solve the problem of beginnings. There is no need for a singular creation, only endless time and probability. But the deeper one goes, the more disquieting it becomes. In a statistical world, smaller fluctuations are far more likely than larger ones. It is easier for chance to produce a single self-aware mind with a convincing set of false memories than to generate an entire cosmos with billions of years of real history behind it. That possibility cuts close to the bone. It suggests that what we take as cosmic history may be more extravagant than necessary. The galaxies, the ancient past, even the continuity of experience could, in principle, be part of a vast but minimal illusion. Not because anyone deceived us, but because probability favors the smallest dream capable of mistaking itself for a world. And yet here too there is a human lesson. We do not live by certainty alone. We live by coherence, by shared evidence, by the patient trust that reality is deeper than our fears. The Boltzmann vision reminds us how fragile knowledge can feel at the edge of philosophy and physics. But it also asks a quieter question. If meaning can survive even under the pressure of radical doubt, then perhaps truth is not only what exists, but what endures the longest under honest scrutiny. What if the universe remembers more than we do? Look up at the night sky long enough and it begins to feel less like emptiness and more like archive. Light travels slowly enough that every star is a delayed message. Every galaxy arrives as it was, not as it is. Astronomy, in that sense, has always been a study of memory. But some theories about what came before the universe push that idea further. They suggest the cosmos may carry traces of earlier realities in ways too subtle for easy recognition. Not evidence in the dramatic sense, not a hidden inscription waiting to be decoded in a single flash. Something quieter than that, a bias in the background radiation, a mathematical symmetry that seems too elegant to be accidental, a structure in the laws of physics hinting that our universe did not emerge in complete isolation, but inherited its opening conditions from something older. This possibility lives at the meeting point of several ideas: cyclic cosmologies, bouncing models, conformal transitions, even holographic descriptions in which information is never entirely lost, only transformed. Each framework differs in its mathematics and its claims, yet they share a common intuition. The beginning may not have erased everything. It may have filtered, compressed, or translated what came before into forms we only dimly know how to search for. That notion is emotionally powerful because it mirrors ordinary human life. People are shaped by inheritances they cannot fully name. A gesture survives a grandparent. A silence survives a wound. A family story, half remembered, still alters the choices of someone born decades later. Continuity does not always require full recall. Sometimes what lasts is not the event itself, but its pattern. Perhaps the cosmos is like that. Perhaps our universe carries ancient influences without possessing a conscious history of them. What preceded us may not survive as narrative, but as tone, tendency, structure. A prior reality may be gone in every familiar sense and still remain present in the way ours unfolded. And that leaves us in a moving position. We are latecomers in a universe that may itself be an heir. The oldest truths might not appear as answers spoken clearly, but as faint consistencies across darkness. To study the cosmos, then, is not only to ask how things began, it is to ask what survives when beginnings are too violent for memory, and whether understanding is sometimes the art of listening for inheritance inside silence. What do we become when every origin story remains incomplete? By the time we reach the far edge of these theories, something subtle has changed. We began by asking what existed before the universe, as if the answer might wait like an object behind a curtain. But now the curtain itself seems altered. In some visions, there was a universe before ours. In others, an endless field of inflation, a prior cycle, a quantum fluctuation, a hidden boundary of information, or no meaningful before at all. The possibilities do not settle into one clean conclusion. They widen the question until it begins to reflect us back to ourselves. That may be why cosmology feels so personal even when it speaks in equations. These theories are not merely technical attempts to describe the first conditions of matter. They are ways of confronting finitude. They ask whether beginnings are singular or recurring, whether existence is contingent or necessary, whether memory is fundamental or fragile. And beneath all of that lies a recognizably human concern, whether anything we are or love belongs to a larger continuity. Science cannot promise consolation, and it should not pretend to. Some models suggest radical indifference. Some reduce our universe to one event among countless others. Some imply that our need for first causes is itself a local habit of thought, not a guide to ultimate reality. Yet none of this empties the world of meaning. If anything, it places meaning where it has always lived most honestly. Not in cosmic guarantees, but in the encounter between mystery and attention. We are a species that emerged late on a small planet under temporary skies, and still we build instruments, languages, and mathematics capable of reaching toward the first instance of everything we know. That effort matters, not because it conquers the unknown once and for all, but because it reveals a rare kind of courage, the willingness to keep asking even when the answers grow stranger than our oldest myths. So perhaps the final chapter before any conclusion is this. The universe may never give us a simple origin story, but in searching for one, we uncover something equally important. That curiosity is not a detour from being human. It is one of the clearest expressions of it. At the edge of what can be known, wonder is not a weakness. It is the form understanding takes when certainty falls away. So what existed before the universe? After all the models, all the mathematics, all the careful acts of imagination, the most honest answer is not a single theory, but a landscape of possibilities. Perhaps there was an earlier cosmos that collapsed and gave rise to ours. Perhaps reality renews itself in endless cycles, each world inheriting only the barest trace of the one before. Perhaps our universe is one bubble among innumerable others in a larger process that never truly began. Perhaps it emerged from a quantum fluctuation, or from hidden information on a boundary more fundamental than space. Or perhaps the question itself fails, because time did not exist in any recognizable form until the universe did. Each possibility carries its own emotional weather. Some are expansive, opening onto a multiverse beyond comprehension. Some are austere, stripping away the comfort of a first cause. Some suggest inheritance without memory. Others ask us to accept that human intuition may not be built for the deepest structure of reality. None of them offers a final resting place, and maybe that is not a defect of the search, but its most revealing outcome. Because the story of cosmic origins has never been only about the past. It is also about the present tense of being alive. To ask where the universe came from is to ask what kind of world allows consciousness to appear and begin wondering about its source. It is to stand in the brief light of one human life and feel with unusual clarity both our smallness and our reach. We may never know whether the cosmos had a first moment, a previous life, or no beginning in any ordinary sense. But the search itself has already changed us. It has taught us that certainty is not the only form of wisdom, that humility is not surrender, that mystery, when approached with rigor and care, can deepen rather than diminish our sense of belonging. In the end, perhaps truth is not always a door that swings fully open. Sometimes it is a horizon receding as we move, inviting us onward, and perhaps that is enough. A universe able to produce questions like these has already given us something extraordinary, the chance to witness existence, however briefly, and to answer its silence with wonder.